Good evening to all. I am Shruti from CSM Department of Section C. Today I am going to discuss about Clausius-Mossotti principle. Introduction to Clausius-Mossotti principle. The Clausius-Mossotti principle is a fundamental concept in thermodynamics and phase equilibrium. It describes the relationship between vapor pressure and temperature for pure substances. The principle is essential for understanding phase changes and designing thermal systems. And moving to the historical background of Clausius-Mossotti principle, the principle was developed through the combined efforts of Rudolf Clausius and Mossotti in the early 20th century. It builds upon earlier work by Clausius on vapor pressure and phase transitions. The principle has since become a cornerstone in the study of thermodynamic properties of substances. Let's see the fundamental concepts. The Clausius-Mossotti principle relates the vapor pressure of a substance to its temperature. It assumes that the substance is pure and in equilibrium between its vapor and liquid phases. The principle provides a mathematical expression to this relationship. And moving to the mathematical formulation, the Clausius-Clapeyron equation is the mathematical expression of the principle. It states that the rate of change of vapor pressure with temperature is directly proportional to the heat of vaporization. And moving to the assumptions and limitations, the principle assumes ideal behavior and negligible volume of the vapor compared to the liquid. It is most accurate for small temperature ranges where the heat of vaporization remains constant. Deviations occur at high temperature or high pressures for substances with complex molecular interactions. And practical applications, the Clausius-Mossotti principle is used to estimate vapor pressures at various temperatures. It assists in designing distillation process and other separation techniques. The principle helps in predicting phase behavior in chemical engineering and environmental studies. And moving to the significance in thermodynamics, it provides insights into the energetics of phase changes in pure substances. The principle links microscopic molecular interactions to macro thermodynamic properties. It is essential for calculating boiling points and designing thermal systems. And moving to the experimental determination, vapor pressure data are typically obtained through experimental measurements at different temperatures. The Clausius-Clapeyron equation is used to analyze this data and determine vaporization enthalpy. Accurate data are crucial for reliable application of the principle in practical scenarios. And comparison with other models. Unlike empirical models, the Clausius-Mossotti principle has a firm theoretical foundation. It complements other thermodynamic principles such as Raoult's law and Dalton's law. Combining these models allows for comprehensive analysis of phase equilibria. And finally, conclusion, the Clausius-Mossotti principle is a vital concept in understanding vapor-liquid equilibrium. It provides a quantitative relationship between vapor pressure and temperature for pure substances. Mastery of this principle is essential for professionals in thermodynamics, chemical engineering, and related fields. This is about Clausius-Mossotti principle. Thank you.